So welcome everybody, lovely people. I'm very honored and happy to be here today with you and to say something about Redhat, technologies, OpenStack, mainly OpenStack, that's why we're here, right? So, I'm gonna just give you a quick introduction about myself and then I'm gonna ask two questions to set the stage. So, my name is Sergey, forget the surname, we don't play surnames in Redhat. Names are important, surnames not. Right, so I'm a solution architect in Redhat. I'm doing that for 2 years. I'm focused on storage and infrastructure. So that's why I'm here today, because all of my other colleagues are doing more important business-related stuff, and I do the boring stuff. So that's my goal today, right? And before coming to Redhat, I was doing 7 years pre-sales for HP in storage. So storage mostly is my background. OpenStack is very, very familiar to me, but I'm not super heavy expert. However, I'm sure I can try to answer most of your questions. If not, I will find a person who will definitely answer these questions. But on a certain level, we will talk. Right? Okay, so just before hitting, it's going dim. Before going into this thing, I just went one quick question. Anybody of you who don't know what Redhat does? Great, super cool. Because sometimes I get an audience who don't know. And maybe a stupid question, anybody if you don't know what OpenStack is? Cool, I'm having the super technician guys here today. So,
wow.
All right, I treat you so, right? So, please forgive me. So, okay, so subject for today, Composable IaaS plus, or Infrastructure as a Service plus, and the future. So, just a hint. First, we will talk about what is IaaS and what is IaaS plus. For us in Redhat, that's a bit different things. And then we will talk about composability and why composability matters in the data center. Why we should even think of composability of OpenStack in general, what benefits it brings, etc. Then we will smoothly transition to features which are either in progress or not yet supported but will be soon, and some great future ahead of us. I have 30 slides for 45 minutes, so if I skip something, please excuse me. Slides will be then, of course, distributed. So if you miss something, feel free to download and to check whatever you like, right? Oh. Right, so start with core. Okay, so the message, or at least for Redhat, the message, what should an OpenStack do is to connect two different types of people, two different roles in an organization, developers and administrators. We have a very fancy term, DevOps. That's not maybe the thing, but it's very close, and I will explain why in a bit. Okay, so why we should ever consider. All right, so let's leave it for now. We will get to that later. Okay, so infrastructure as a service, OpenStack, classical stuff. So your layer on the bottom, that's what we all know and love. And then what is IaaS Plus from Redhat perspective? These are things which sit on top, which give you those user space or those goodies which you actually look for today. So just Nova and Neutron and Swift are not enough. We need something to measure. We need some telemetry in general. We need to provide billing. We need to do stuff. Then, of course, data processing. Everybody wants to not only acquire and store data, but also make a business profit out of that, right? So we need something to process that. Also, file shares, orchestrations, the identity management, because our environments in the data center are getting more and more complex. Even though Gartner says we only have 2 operating systems like Linux and Windows, but never happens. So we need to think of identity as well. And here on the side we have something which we call internally a director, but that's based on a community thing called OOO. That's basically our productization of the OOO. And you can imagine this as an agent or a daemon which runs the whole theater here, right? So he acknowledges and works with the bottom part and also provides the top part for us. Right? So how do we actually connect? So how do we actually find the penetration point for users and administrators? For us, it's about, the starting point there is to give a space where you can interact. And that space is a user portal. The user portal is based on the mentioned director, which is a productization of the OOO. So imagine you have an agent and that has a GUI basically on top. And that GUI is flexible depending on your role. So if you are just a user or a tenant or just a classical, let's say, give me I want, So that's your case. So you have your specifically designed user space or GUI. If you're an administrator, your user space and your console is getting bigger, so you have much more functions. And on top, you as administrator can say what all features and what all buttons and what all functions should be there for the tenant. So that's the first step. So how do we actually penetrate those two groups? So we create a field where they can play. Right? But behind that, something should work, right? So we just don't only provide the fancy GUI like, oh, click here, do that. But also there should be some logic behind. And the logic here is setting the rules, setting the policies which are critical. So in this case, both users and administrators have the same more or less set of tools. So they can use Horizon, they can use CLI, they have specific set of libraries, and of course they can access everything via the API, right? So JSONs and XMLs and get whatever. So then we go into the policing. So why or how should one user do things which he is only allowed to do? And that's thanks to the policy JSON, which is inside of the keystone, who delegates all the limitation, privileges, and so on and so forth. Also, something relatively new is the keystone domains, which are in version 3, allow us to do something like a domain administrator. So we have a hierarchy of several levels. So you have a super admin, and then you have some sub-admins in different data centers and levels. That's now also possible to create something called domain admin, which is not the top level guy, but maybe he's a bit lower. Like, okay, so if you have a company with 25 DCs and one single super admin, and then some delegated admins to the domain levels, that's the thing. And he also is empowered, and he's, let's say, he has the ability to only work with those tenants who reside on that specific data center, right? Or the domain. Right? Okay? So, back to the fact, what is a director? How does this guy enable getting us from the basic IaaS level to the IaaS plus level, where we get those business resided or user experience resided GUIs like Ceilometer, like Horizon, etc. So this daemon or this agent is basically responsible for providing the whole scenario. So it starts with a basic level of deployment. So you just install this director or daemon or whatever you can imagine that on a machine, and then you start building. So you're saying, okay, so go there, check that node, check the network, set up the OSDs, make the thing we call undercloud. And once the undercloud is done, he is running several scripts or several mechanisms how to verify what's been done on the undercloud level. So he checks your networks, he checks your privileges, he checks your storage, he checks your whatever, and then he gives you a report. Okay, Mr. Administrator, so your undercloud is ready for you. You can deploy the overcloud. Okay, so that's the thing. So it's very, very simple, right? Without going into the details. But the good thing about this director guy is the thing that you can do everything based on either Ansible. So Ansible is integrated into the director. So you can create a playbook, YAML playbook, or YAML code, put it somewhere, and deploy from that. So you don't have to remember all the steps, you don't have to care if it's that or this. So basically it's so automated that you install this director via Ansible, and then this director actually take your Ansible playbooks or Ansible codes and spin off the whole infrastructure as a service. Very automated. The good thing about a director, which makes it a bit different maybe from the community project Triple, is the fact that we implement the pacemaker as the default control plane high availability module. So pacemaker is on board. It actually do support different kinds of load balancers, but we stay with it. In Redhat version, we stay with the pacemaker. Okay? I will skip. Yeah, sorry, too many slides, too much information, so I'll go to the interesting part. So, the basic stuff. So when you do the undercloud, which is the IaaS level for us, this is just a daemon who does the dirty job, right? So he checks those storages, networks, controllers, and computes, and just presents you with the result. So this is basically a way how to look at it. So it's a GUI, the same GUI as I've shown you before, the administrator part, and here you have a validation workflow where he goes through a set of tasks, analyze them, and present you with the result. And if something is wrong, you can actually not only see it inside of some GUI, but he can do some alerting, messaging, and stuff like that. Great thing about this that if you're doing this through the Ansible playbook or through the YAML code, it actually gives you a hint how to manipulate your YAML code or the Ansible playbook in order for this to be fixed. So you don't have to actually even know the Ansible, or the language there is pretty simple. It's pretty simple, it's human readable, it's very understandable. So you don't have to like be a super programmer or super admin to do this kind of stuff. It's very easy, very easy. Okay, so with this, I'm going a bit deeper right now. So typically we have 5 roles, right? So whenever your directory is installed, he's looking at 5 things. He's looking at the controller, he's looking at the compute, and he's looking at the storage. Block and object like Cinder and Swift, fine. We can just, with Redhat, we can just do with Ceph. We're good with that, but nevertheless, 5 roles. I'm just taking this as an example, okay? So don't shoot at this right now. Okay, so 5 roles, and typically there is a set of scenarios and set of interconnects, APIs, and networks which you have to have on site in order to raise the first IaaS level. But here comes the funny thing. You don't have to put it in a single namespace anymore. And that's where the composability, where the strength of the Composable IaaS Plus kicks in. So right now, you don't have to have everything, or you don't have to strictly stick to those roles. So yeah, we have 5 roles, we know of that, that's cool. But now, I as administrator can decide where I compose those roles and how they're composed. This example shows a controller node where I have all the stack of my necessary IaaS Plus things, and then I can decide that I can actually take those bits, take those roles or pieces of the role and put it on a different nodes, or even in a different data centers. Due to the fact that I've mentioned that we have a pacemaker on board, which is actually a load balancer, right? Or high availability load balancer, you can actually stretch this to even cross data center link. So why? The logical question, why should I do that? For example, I have my Neutron somewhere already started, and I want my new OpenStack installation to talk to that guy which is sitting somewhere else. When we're going deeper and deeper, we will show the NFV part, because NFV really goes after this. NFV wants to be composable. It actually pushes you to be composable, because in NFV you don't care about fancy stuff, you care about networking. And networking is crucial, because there it's a bit different story. So this composability have multiple use cases. However, the best case is that you actually can take multiple things or multiple bits of the role and spread it across different nodes and different data centers. Here's a bit detailed, so how you can actually spread between different types of nodes. So here we have controller, database, and messages, and we can say that we want to stretch it and put it on a different node. Okay? What else? So besides just splitting the roles apart, what other benefits this brings us? So one of the great benefits of composability is the upgrades, are upgrades. So typically when you're doing an upgrade of your already existing OpenStack installation, you need to be very careful, right? So if you're upgrading just a part of the installation, then maybe it will bring some problems around. And these composable upgrades are directly aiming at this part. So they actually enable something we call upgrade task. So you can put a task inside of your upgrade workflow, which can then specify what specifically you need to upgrade. It's Ansible. We all in Redhat love Ansible right now. For us, it's recently acquisitioned technology, so we try to put it everywhere. Ansible. Right, so here's the example, right, so how it looks. So as you can see, the code or the commands themselves, the text, they are pretty straightforward, right? So there's no hidden C++ coding and etc. So it's pretty straightforward, human readable, very, very, very transparent. So this is an example how you can actually make a parameter called task upgrade and do it basically running. So Heat orchestrates this from the YAML playbook or YAML code and runs it. However, what is actually next step? So that fine is that part is fine. Okay, so I have a parameter where I can specify what upgrade task should I run. Okay, I get that. It's cool. But what does it bring like to my daily basis operation? So I couldn't do it myself actually. So even without this parameter, I could actually write YAML code where I can run certain same stuff, more or less. I mean, if you guys are at OpenStack admins, you maybe know this. But what is actually the next step and what makes it different, why we need this pre-step, is to make this as a playbook in general. So we want, the ultimate goal of this is to create a set of tools which will allow the administrators not only to specify some certain workflows, how to upgrade certain stuff inside your OpenStack, but we want to do this and publish that as a playbook later on. So that means that once you build your knowledge base, you know your workflows, we want that not to be abstract and in your head, but we want that to be as a certain library of steps which you can then delegate to your, let's say, subadmins or to your compliance and or audit officers who can check that if that's fine from the compliance perspective, etc. So that brings another things on play. So with composable upgrades, we are going towards making this rollout upgrades on OpenStack, individual modules or the whole, as let's say a library of steps what you need to do. And that's how we see it. So we have this YAML, which is then integrated into Ansible and stored as an Ansible playbook on your repository or in Git. Okay? And then also the great thing about this is that in OpenStack, as I mentioned earlier, we have some critical bits and parts which we don't want to include into the upgrade. So here, this disable upgrade deployment is something which we necessarily keep in every single composable upgrade playbook, is that certain things, due to compliance reasons, security reasons, or whatever, we are not trying not to upgrade. So you can imagine this as if you have a certain subadmin who is only allowed to upgrade, for example, Ceph. So he's your storage guy, you know, he's reliable, he knows that there's a new version of Ceph, he wants to adopt it, so you can allow him inside of your director to run the composable upgrades only on Ceph, and to present him with a set of Ansible playbooks which are only related to Ceph. It makes things a bit easier from our perspective. So composability, not only stretching your roles through different nodes or different data centers, but it's also about upgrades, about upkeep, about day two. So you don't have to have everything in your head and know your infrastructure from 0 to 100%. But here is a nice tool which can help you do these things more efficiently and maybe, let's say, think of compliance and audits as well, right? Okay, so going further. So upgrades, clear. Now we can think of a situation where we not only upgrade the modules or, let's say, the components and the roles themselves, but we also want to think about, let's say, not day 2, but day 4, week 1, or year 2. And that's about how I actually upgrade the whole infrastructure, right, or the whole deployment. And here we have actually very clever thing. And the logic is very, very similar to the previous composable upgrade scenario, but here we only do the thing that we give you, let's say, a logical abstraction. So here's my, let's say, here's your day today. This is something which I'm planning, maybe for future. And there's a couple of nodes which I might think of adding to my OpenStack in a week, or in a month, or in a year, whatever. And I can actually, due to the fact that I now have this composable stuff, I can actually pre-prepare or give an instruction to my director and say, listen, director, I want these nodes to be prepared, for example, in a month. I want you to check them right now to see if the undercloud and the overcloud are deployable there and leave them be. So I can back there in 2 weeks or 3 weeks time and deploy them. Why would you do that? One single reason. Once those are checked and everything is prepared and configured, then the deployment of the overclouds takes minutes, hours, but not weeks and not months. So you don't have to do the whole cycle again. So director knows these nodes, he knows that they are compliant, that the network is good, that the storage is good, that the compute is right, and then it's just boom, run it and add it to the OpenStack installation. This is one of the, I'm just jumping, but this is one of the, I wanted to give as an example. This is a scenario where composability really matters in things like this. Don't try to read it, it's unreadable. But this is a classical example of why composability matters, and that's NFV. Because in NFV, we need really to consider different options for different building blocks. All right. Whew. I know I was very fast, and maybe it's too many questions. Please remember your questions. After we're done, I'm here for 2 more hours to stay, and then I have another presentation. So we'll have time. I will have time to answer some of those, right? Or I'm having a visit card here. So if you think or feel that you want any assistance, please come take a card, shoot me an email. I will take my time to answer you 100%. Okay? Work in progress. So what do we actually do right now? What we will do and what's already in place but not yet supported for production. Because Red Hat is actually productizing or making enterprise products out of the community. Right, so one of the critical components, and I know some of the speakers here today will talk about this. I saw the agenda and I think, yeah, this is cool. I will just mention it. So in case there are questions, maybe we can, deliberately talk. And guys from the foundation definitely know this. So what is one of the most painful scenarios right now is the situation around trusts and token expirations when you try to get an image into your image store. So imagine the situation. So you ask for an image, and you have your valid token. You are okay, you're authenticated and everything. And then you start the process, but the process for some reason takes hours and hours of time. And meanwhile, you're actually waiting for the image to be stored in the image store. Your token fails. It happens. It's built for you for 1 hour or for 2 hours, so depending on your security policies in your organization, that may be, I don't know, 3 hours, but the image is so huge, it takes super long time. And then what typically happens? It gives you an error. Sorry, your token is expired. In spite the image was 99.9% stored. Ciao. So that's, I don't know about you guys, but at some of my customers that happens. And that's terrible, like really terrible. So what's the workaround here is that we need to somehow allow Glance to talk to the keystone and to ask, hey, Mr. Keystone, is the trust active? Is this guy a valid guy? Yeah, I have his token, he presented it, but if the token fails, what? I cannot decline. So this is a workaround. So we see this as a great workaround to make Glance talk to the keystone directly and get the information if this or that user is valid, it has the authorization to put the image in the image store and so forth and so on. This is very important, very key, and it happens a lot. Well,
is it just a problem with the Glance we want when you have Glance register as well, right?
No, I think it persists. It's not bound to the version. I think that's more, let's say, related to the keystone than to Glance, actually.
I mean, usually we see this kind of problem when the keystone API or the Glance API is talking to the Glance register, that's the REST API call.
Yeah, exactly.
And that's when you have the problem if you have something like an upload longer than 1 hour.
Yeah, but with the Keystone previous version, when the Glance called the API to the Keystone, it didn't have a certain set of parameters which he had to take from the Keystone to answer if this user is valid and if his token is expired or not. So I think that was the problem, like not the fact that there was no communication. The communication was there, but the parameters of or what information did actually Glance take from the Keystone. The bit was what is the trust that was missing. So the trust was not full like it should be now, right, in version 3. Right. Then the next feature, which is cool, and it's also pushed by us by NFV project, it's the collocation of Ceph and compute. Makes sense, definitely, because it saves our space and basically resources. Disks are specifically NVMEs and SSDs, which are highly used in NFV surroundings. Those are expensive. So great thing. I think this is something which is already, let's say, supported. So we can actually do this in production right now. But there are certain limitations. I will not tell you which ones, but there are some. So we can already collocate Ceph with compute. Right? Okay, so features which are in the product, but are not recommended for production right now. So that means that you can install it, you can try it, it works, but whenever you put this in production and something fails, it will be very complicated. So if you are heavily boosted, I want this today, come to me, we will talk and we will hopefully make this happen. For community people, you know this should be already tested, verified, and sound and working. So just from the Redhat perspective. So replication on Cinder, I think this was, as this is a normal feature, like say load mount, this is nothing super cool here. However, the high availability within Cinder is another thing, and this is something which we heavily look into because high availability is critical, specifically for the RBD itself, and that's something which needs to be there. Manila is already in place. FFS is a cool thing; it works. Octavia is basically, well, it's tearing off the Neutron as a sub-project and then presented as a standalone project. This is as well pushed by an NFV because load balancers are sometimes critical in a huge NFV deployments where we have tons and tons of machines. Then we need the load balancer to be agile, and we actually, in some cases, need to raise the load balancer even before we do raise and put the overcloud on top of it. So very interesting stuff about that Octavia. This is something very interesting. Maybe I will skip to the next one. Yeah. Okay. So DPDK accelerated OVS. This is something which we try now at one customer for production. It actually works great. However, I have my own personal experience with this that the performance boost is not that heavily actually as it was expected. So yeah, there is some boost. It works in a slightly different manner, but the expectations were much more. Maybe the fine tuning is not correct, but what this actually should do, it should take the actual kernel out of the plane, out of the game more or less. So basically what we want to achieve, we want to put the user space as closer to the NIC level as possible. So we want to allow our users to have everything as one batch with including this switch. So the switching in between the NIC and the vSwitch is as fast as possible. As I said, my personal experience, this works, but it works in a very different way, or strange way. Alright, so DPDKs, this is some general information about how DPDK actually works and stuff, but I think some Nokia people from here will definitely know what this is. I don't need to explain. Alright, so VLAN aware VMs. This is a cool stuff actually, because when your VM is actually aware of what VLANs are actually working and how they act, what information they bring, that brings certain new level to awareness perspectives of that VM. So I'll put it like this. So typically what we do, we have VNIC, right? So and there's something some VLAN flowing there, and this is like a neutron port, right? But we're trying to take several of the neutron ports and put them in a trunk. So it's kind of V-trunk, but here we call it a neutron trunk port. But that's great stuff. So for NFV again, or for heavy network-based installations, that brings certain benefits. Benefit number one, you can accumulate and trunk several VLANs on one single VNIC and allow certain new level of, let's say, awareness for the virtual machine running whatever, vSwitch and so on and so forth. And I have a small picture here. So yeah, so basically this is how it's architecturally it works. But one specific customer which I remember who is now trying this, they're analyzing betting sports. So they have huge cloud-based application of customer inputs where they do the bets, and those bets are basically attached to the huge database behind that. Also they have some SAP HANA there analyzing stuff. Oh, super complex, super terrible installation. And they decided, what if we will put some extra switching capacities and some extra vSwitches in our IaaS? And they said, well, let's do a proof of concept for OpenStack. So they took, I don't know, this is not a secret, HP hardware. They put the OpenStack on the bare metal due to the fact that we have ILO support in Ironic, and it's very, very easy, so we can basically deploy on bare metal. So they tried it, they put this one on top, and actually what they were aiming for, that they want to elastically raise as many VMs as needed due to the spikes of the loads of customers coming to their cloud installation or cloud application. And they had a graph where they showed that between when the match starts, when there's a Bundesliga or whatever, English Premier League, and when they open the betting window, the demand of the application or the network boost raises to 110% of their current capacity level. So they need to expect the network saturation. But here, when they adopted OpenStack, they actually created a playbook, or they have a certain, let's say, workflow. When they see that this is coming, they're proactively prepare like tens of Open vSwitch machines, and they expect the load. And actually display themselves, or in the end of the day, when the proof of concept was good and everything was fine, they suddenly came to a simple analytics that, in the matter of fact, they don't actually even need this. They don't need the trunk. They're totally fine if a single machine with vSwitch will be sitting on single VLAN. For them, the compute overhead which they get from getting the neutron trunk port was so big that they didn't have the good money impact. So where I'm aiming is that this technology is really cool. You can actually aggregate multiple VLANs into one single neutron port trunk, but it has its downsides, right? So it's not for everybody, but it's a very interesting bit of technology. Okay, ironic, super cool stuff. As I said, there's multiple integrations with this. My second part of the presentation later on, I'm be focusing a lot on how things are integrated, not only from the perspective of different hardware providers to the OpenStack, but also how the whole chain from the bare metal to X is done. Ironic plays, of course, a great role. Its functions are evolving all the time, and there's a lot of contributions from the community and from different hardware providers. So it's a really, really long talk about it, so I won't want to go into details much. Of course, VMware, we love VMware, we cooperate, we are friends. This is a physical message, right? For now, I cannot talk about community. I'm not very deep engaged in that. It's we support VMware, but the support is done basically through the hypervisor driver. So it's not native, right? So it's well, kind of native, but not actually native. So it's a driver sitting in the compute cluster, which is talking to vCenter, and that makes the whole thing work, right? Okay, well, I'm so fast, unbelievably fast. Okay, gentlemen and ladies, of course, friends. If you have any questions, now is the time. Maybe I can try and shoot and answer some of those. If there are no questions or you feel shy, my cards are there. My email will be on the first slide. I'll get back. Also, if you need any assistance here, specifically in Hungary, ULX partner company, they're there on the Redhat booth. Feel free to talk to them. They will definitely be of assistance to you. If I can be of any assistance, as I said, my email. So thank you with this. I will leave you for your further lections. And if you're interested in more integration stuff about Red Hat, please come to my second lecture. Thank you very much.
I guess any questions that's out there, can we still ask in the upcoming still 10 minutes if you're available?
Yes, sure. Come to me. Let's talk. I'm here.
You can open it.
Yeah, so the diaper you mentioned, is it part of, so it's a free stuff, so like part of could be used with RDO as well, or is it just for the enterprise Red Hat stuff?
The simple answer is if you're interested in things which are happening in the product, because let's put it like this, OpenStack Foundation, we are there. We are actually actively putting things also inside of it. RDO is, I should not be saying this, but it's not as good as it should be, from my own perspective and from the, let's say, the feedback from other customers and partners. So, if I should encourage you to try RDO, it's up to you. What I can do specifically for you, if you come to me and say, hey, sorry, I need to try and test some stuff, I can actually give you an evaluation.
Yeah.
And we are allowed to do that. I'm giving it openly. So if you're interested in giving a try, 60, 90 days for the product,
Mhm.
get my visit card, come to me, I will help you with that, definitely. I'm not encouraging you to try RDO. You can, it's up to you totally. But if you really want to sense the feel of the product, evaluation is the best.
Yeah, I'm just wondering.
Yeah.
I have heard there was that the Packstack installer in
Yeah.
RDO is also going to be replaced with this one.
Yeah.
So the director. So
Also-
that's going to be a kind of a common sense and
Yeah.
sort of stuff as well. So that's the
Another thing is that there's OpenStack with, I'm thinking with Rackspace or with some public cloud provider. I think OpenStack can be also purchased or tried by GC. So if you have a GC instance, you can order an OpenStack as a service there. But that's not the same if you try it on like in-house, right? So it's somewhere you know where and you know what's happening. So literally, if you want to try it in-house, I mean the product version, I'm really open for MOs. If you want to try RDO,
Yeah, I know the limitations.
Sorry, this is too much of a duplicate question, but I missed the first couple of minutes because it was hunted for chair. So is it the correct understanding that we were talking about undercloud and overcloud? So is the correct understanding that the undercloud is basically with which you provision the overcloud, which eventually will then provision your virtual machines for your tenants? Is that the correct understanding?
Yes. So the workflow is like this. You actually prepare the undercloud, so the daemon do all the dirty job. Then you raise the undercloud, which is basically a set of tools, set of stuff which are on the bottom. And then you actually provision the overcloud, which is on the top, including all the modules.
And for the provision the undercloud, you're basically using, or the undercloud itself is basically a set of Ansible playbooks.
So everything from the installation of the daemon itself up till the very top is all provisioned in YAMLs or Ansible playbooks.
Further questions? Then I have one duty still. Thank you for the presentation.